All right, everybody, thank you so much for coming out. My name is Todd Terrazas, and I'm the founder, president, and executive director of the AILA community. Who here's ever been to an AILA event before? Awesome, and who's their first time to an AILA or SoCal Analytics event? All right, good to see people. But anyways, thank you all for coming out. We're really happy to be here, obviously. We're here at Phase 2 co-working space. They're one of our core partners, and we love throwing events here, so thank you so much for having us tonight. So AILA, if you don't know, we are a nonprofit. We've been doing this for over 3 years. We focus on all different industries. We allow the non-technical to participate. We really want to develop a real community focusing on AI for social good. And so the way we go about doing that is by convening through events, socials, workshops, summits, hackathons. Data challenges are getting to become very popular for us. And we'll focus on different themes throughout the year. So everything from entertainment media, fintech, sustainability, healthcare, life sciences, the future of work, you name it, we usually will talk about it throughout the year. And so our mission is to catalyze innovation through education, conversation, and collaboration. And so events like this are really meaningful to us because it's a time to hear from brilliant people in their work, this time around deep learning, and we're very grateful to be partnered with Accenture for this event. And so I'll stop talking now, but I would love to introduce you to Zhang from Accenture, and he'll be giving a talk in a second. So here's Bo. Thank you.
Hello everyone to come to this event, and that's the first time Accenture is co-hosting this type of meetup event, and we had this type of event in some other locations like Seattle and in Bay Area. It's super successful, and so we really want to be part of the community and to make sure that we get engaged with everyone who have want to learn more and want to participate into this AI type of discussions. That's great. So I myself, I'm Zhang. I'm lead the Accenture-wise data science and machine learning engineer team, and I'm based in San Diego. I mean, come up here for this event. It's really looking forward to learn with everyone here and together. That's a great opportunity. I've been a lifetime data scientist for my entire career, and deep learning has actually changed my thinking about how machine learning can be. And let's start from there. I mean, I'm not really a deep technical guy anymore, and so but at least I can share a lot of experience from how those type of machine learning stuff can be used in the real world problems. So I mean, get started on my stuff, and I will do it really quick, because I'm not so deep in this thing anymore. So. One thing I want to mention is that, I mean, where in the industry is, machine learning is really used, right? And actually, machine learning is used in the industry for many years. And one part of it is from very early days, like in 1990s, around those period, a lot of so-called real-time decision-making has actually been driven by machine learning. And one use case is that fraud detection. So you swipe your credit card, and the data sent to the credit card issuer bank, and the bank basically run a machine learning, actually a fully connected neural network model, and based on your transaction data and all your transaction history, which they get from the database, and they put all those things together, massage them, and they run a fully connected neural network and generate a score. The score is supposedly proportional to the probability of fraud of that transaction, and that score returned back to the POS device. Basically, the cashier see that his or her screen, and they will show, I mean, decline, approve, or show, I mean, check ID, and all those things, all based on the score. I mean, basically, that's the type of things, and this type of business problem and how it really operates on the back end. I mean, basically you have a stream of data. The stream of data could be the transactions when you check out. It could be some customer event like I made a phone call to a customer service or whatever. I mean, all those events generate a stream of data. In the stream of data and machine learning, where it really helps is on some decision-making process. And basically, whoever interacts with the customer or in this process of a business operation, he needs to have some support from this machine learning system to help him or her to make decisions. So then how the system really works. And in the past, there is some limitation of the hardware, limitation of the I/O and all those things. So people figure out a quite smart way of doing things. Nowadays we call it lambda architecture. Basically, the data actually have two streams. One is through this real-time decision making, but another stream of data coming to the data warehouse. And data warehouse data, I mean, like say daily batch data, I mean every day it accumulates data into data warehouse. The data warehouse data get accumulated and get profiled. Profile is basically a term to cook it into some key. And then this thing can be served, this type of cooked data, I mean, or feature engineered data can fit into some real-time decision engine. The decision engine is a fancy term of some equation, right? Some equation with, so the real limit of this thing, the real constraint of a machine, scoring engine is that the calculation complexity have to be fixed for each transaction so that you can really serve the real-time SLA. So this type of thing, and the batch data, you cook it because it's heavy lifting calculation there. You do a lot of aggregation and those things there, and in a daily basis, fit into a profile database or something like that into the real-time engine. And the real-time engine get the data from the stream, query this database, and which not necessarily the most up-to-date, but it's up-to-date till last night, and then serve it up and serve the decision up, the score up. So that's the process there. And why this process is why I want to mention the deep learning kind of discussion is that that actually provides us a framework of all the previous also called traditional machine learning model in the industry, how it works, and as a data scientist, as me, so-called traditional data scientists, they have this thing built in their head that everything has to be feature engineered, and the feature engineer is the key of a good model. Basically I carry that kind of concept all the way until very later piece of the page, and I got shocked by some research, some study we did. So what are the features? So features are pretty straightforward thing. Like if you for fraud detection, some velocity is a feature. Basically, how fast you swipe your card. I mean, you swipe your card 5 times in 2 hours. I mean, but every day typically you swipe it maybe twice a day, and instead of 5 times in 2 hours. So that type of measure could be indicator of fraudulent transactions. Some other features like distance from home, right? I mean, how far you travel from your regular shopping place, and how frequently you do so, right? And also like transaction time. I mean, in some weird hours. I mean, you have your typical working hour and live hours, and some strange hours. I mean, those things are the so-called signals of the target you try to predict. I mean, the model, whatever model I'm talking here are pretty much the classification model of positive, negative, those type of classification model, right? So those are the signals, and my generation of data scientists have this mindset of saying the best data scientists can have this common sense, who can actually figure out how to create those features from the data and create new features so that I can build better model. So that's a pathway. And for the modeling part, we still, I mean, in the old days, it's still neural network, and all those things are already available. It's just the mindset is that I need to feature engineer things before before I cook models. But if you really check those features, and majority of those features are frequency related. I mean, basically it's time sequence related features. I mean, things like frequency, speed, and recency. I mean, basically how close to the last transaction till now, and all those things. And also some of those features are frequency or recency on some categorical variables, and all those things are at least 80% of so-called features are actually related to this type of features, and most of the well-defined business models, business machine learning models, are related to the time sequence type of data. So that lead to something. That lead to a I use another. Let's use another example of this type of modeling. It's not fraud detection anymore. It's a so-called churn prediction. So churn is another very standard or very well understand business problem in the subscriber-based business, like telecom, your cell phone carrier, and like Comcast, and like those carriers, right? So subscriber-based business, and the key problem is the customer acquisition, basically how I get customer from other competitors, and then there's customer retention, and then the churn is a standard problem there, and how to predict whether a customer will leave my company and join some other's program. And so one key thing is that in this churn prediction problem, it's similar in the sense of fraud detection. Is that it's event based, and the event could be you paid last month's bill, or the event could be you call in and check what's the rate for next year, or something like that. And then, but each event could trigger a score and say, based on the current event and all your past behavior, what's the likelihood you will churn in the next month. So that's a setup of the problem. But in that sense, there's no real difference between this type of modeling and fraud detection modeling, right? And but the real thing comes when we start to get to more current days. About 4 or 5 years ago, I cannot recall what exactly the day, we got this project from a client, and we are working on an RFP, and basically it's a client set up a problem, and we are trying to be the best vendor for that problem. And the problem is a churn prediction problem, and we have a team already in client set up, and they get access to the customer data already. So there are two schools of thinking. I mean, I'm one school of thinking, and I'm the traditional guy. I'm saying, let's build the best features, and we can think about it, which can predict churn, right? And use those features to fit a neural network model and boosted tree model, whatever, and get a result. And there's another school of thinking, and there's a bunch of young kids and come to me and say, hey, why not use RNN model? I mean, it's a time sequence problem. It's a bunch of events. We pretty much can model it in a really easy way as an RNN model, and let's fit a keras, and let's see what the RNN model does, right? And I'm a guy that's skeptical of everything, but on the other hand, I'm open-minded, so I think, why not? Go ahead, do it. And they did it really simple. I mean, it's way more simpler than I thought. I mean, or I lead a team and created a lot of features. I fit in neural network model, I fit in boosted tree model, all the things. What they did is super simple. And say, okay, here are all the sequence of the customer service event. Basically call in or check my website or whatever. I mean, clients share those events with us without even give us the meaning of them. Basically, they have a labels of the event label. I mean, the label have about 1,000 to 2,000 values in the event types, but they didn't share with us what the meaning of those events, because one thing is that they didn't share. The other thing is that we don't even know their language. It's language wouldn't even understand. So, I mean, the team, the two kids team, come basically saying, okay, let's put an embedding layer there. I mean, basically that categorical variable into a map or into some array, and then put an RN layer on top of that, and then predict the target 1 month in advance and see what is with it. I mean, there's a lot of room this model can be improved, and with other ways and with other fine-tuning, right? Here's the result, and here is I have my team build all those models, and here's the RN model. I mean, the number here is the area under our ROC curve. So I'm not saying, I mean, that's always true. What I'm saying is this thing changed my mind. I mean, so how the heck did it happen this way? I mean, my entire training is broken because of this idea. I mean, this two kids team, and I mean, later after this practice, and I start to using our own model in all type of predictive kind of projects. And what I found is that those two kids are pretty lucky. It's not always like that. Yeah. But what really interesting there is not about the performance itself. It's how easy to get a performance which is comparable to this approach. So that is a real business value to our projects. Is that you can pretty much get into client environment and have a rough understanding of their data, not really deep. Like this type of data understanding is you really need somebody to domain knowledge, a lot of domain knowledge. And this type of data understanding, pretty much none. So in that sense, you can pretty much get a model result comparable to those deep domain knowledge. So in that sense, used to be consulting is all about domain knowledge, and now it doesn't really matter. I mean, it's pretty much if you model your problem right. I mean, and the specific data element is not so critical anymore. So that's a big learning tool. But don't stop there yet. the thing is that it doesn't mean this part doesn't have the value anymore. Because nowadays there's another type of topic coming back is that the so-called model transparency. How to explain your model result, and so-called responsible AI. All those things coming out back. What all those requirements are? Requirement basically say, hey, machine learning, you're too smart. I cannot catch you anymore. I mean, let's make this thing human understandable. So this type of thing is much easier to make it human understandable, and this one is harder. So in that sense, still nowadays there are a lot of use cases using this approach instead of this. Yeah, I'm finished my part. And there's a lot of future thinking around this, and I'm not saying who went to the battle already, but definitely, I mean, the deep learning approach on my type of project, RNC changed the way I'm thinking about machine learning, and but still, I mean, the traditional way has their place.